Hello there, this is Utkarsh Jain, and we would be looking at the formulas of or formulae of derivative investments for CFA Level 2. So there are roughly 30 important formulas, or about 29 important formulas that would be looking at, and these are fairly comprehensive. These would cover a entire spectrum of, or almost entire spectrum of calculations you would be looking at in derivatives. So these are the list of formula, and we would try to also do a few small examples as and when we see the formula, so that we can avoid the need to remember the formula and configure some logic into it. Okay, so let us start. The first one is no arbitrage future price. So what does it mean? That no arbitrage future price is simply the forward price is equal to, or future price is equal to, spot into 1 plus interest rate raised to the time period. So let's call that as t. Okay, so for example, if your spot is 100, risk-free rate of return is 10%, and if the expiry is 1 year or maturity is 1 year, then we will simply say that no arbitrage future price is going to be 110. Now, no arbitrage forward or future price using the continuous compounding. Okay, so now let us say that spot is 100. So spot is 100, and we have been given risk-free rate of return as 10% compounding continuously, and let us say maturity is 6 months, okay, which is half of the year. Then your formula will become forward is equal to spot into e raised to r t. Now in our example, which would amount to 100 into e raised to r is given as 10%, so that would be 10%, and t is half of the year, so I'm going to write this as 0.5. And then how would you do this on your financial calculator? You will say 10% second e raised to x, so 10% second e raised to x. Sorry, I've made a mistake here. We will say 10% into 0.5, which would be 0.05. Then we will say second e raised to x, and then multiply with 100, which will give us a no arbitrage price of 105.127. Moving on to the next formula. Forward price of a dividend paying stock, discrete and continuous. So we are technically looking at two separate formulas here. Okay, so let us say that, so first we will do the discrete scenario. This is time 0, this is time 1. The spot price currently is 100. We are expecting a dividend at 0.25. We are expecting a dividend at 0.25 of 20, and risk-free rate of return, which is given to us, is 10%. Now we have been asked to find out a no arbitrage forward price. Now there are two ways in which we can achieve this. First, we can take this 100 forwards for 1 year, and let's call this as A. Second, we will take this, so in the first formula itself, we will take this 20 forwards for 0.75 years, and we will call this as B, and your final answer would be A minus B. Okay, so this is one way in which we can achieve this answer. So 100 taking forward for 1 year, which means A in this example is going to be 110. Let's find out how much would be this 20 taken forward for 0.75 years. So on Texas Instrument financial calculator, second clear TVM, 20 is the present value, 0.75 would be N, 10 would be IY, compute future value. This will give us 21.48, and once we have, or in fact, 21.48, and once we have values of A and B, your answer would simply be 110 minus 21.48, which would give us 88.51. Okay, so this is the first way through which we can get the answer. Now the second mechanism. So now, second way, let us say Same scenario. This is time 0 and this is time 1. At 0.25 we were looking at the amount of dividend of 20 and the spot price here was given to us as 100. The second way in which we can achieve or get the answer here, now we can say we will take this 20 amount backwards here. So let me call this amount as x. Then we will get 100 minus x, and this 100 minus x we will take forwards again for one entire year and it would get us the same answer. Okay, so let us see if it fetches us the same answer. So first we will take present value of 20. Second clear TVM, 20 would be the future value, 0.25 would be n, 10 would be IY, compute present value. So present value of this amount, this x would be equal to 19.52. So reducing that from 100, which will give us 80.47. And once you have 80.47, we will say second clear TVM, 80.47 is the present value, 1 is the n, 10 is the IY, compute future value, and again we will precisely get the same answer, which would be 88.51. Okay, so we have seen two formulas. The first formula here was, we will say forward price or future price is equal to first present value into 1 plus whatever is the RFR raised to t minus the future value of dividend. Okay, so we took this 100 forwards, we took 20 forwards, we got the answer. This was one approach. The second approach that we saw, where we said future value is equal to spot price, so I should have mentioned spot here, spot price minus present value of dividend into 1 plus RFR raised to t. Whichever approach you use, the answer would always be same on the exam, but I generally recommend using this particular approach for the examination purpose, and there is some reason that you would see later on. Okay, but yes, one of the two formulas can be used to achieve this particular answer. Going forward for the next formula, so yeah, in fact we left with the continuous compounding. So let us say again that we've been given spot price, of 100, we've been given risk-free rate of return, we have been given risk-free rate of return, which is, let us say, 10% on a continuously compounded basis. Now assuming that this is the value of an index, let us say we have also been provided with a dividend yield. Okay, so let us say we have a dividend yield of 3%. Now in case if you see and yeah, of course we are left with maturity. Let us say maturity is 6 months. So in case if you see a scenario like this on the examination, the answer is fairly straightforward. What you need to do is, if you remember the earlier formula, we said forward is equal to spot into e raised to RT, right? The only change that now we are going to make is we are going to say forward is equal to spot into e raised to, in bracket we will say whatever is the R minus dividend yield D into T, so which would amount to 100 into e raised to, in this example 10% minus 3%, that would get us 7%, and since the maturity is 6 months, that would give us 0.5, so which is equal to, using the financial calculator, 7% into 0.5 second e raised to x multiplied with 100, that would give us the value of 103.56, which is the no arbitrage forward price or future price using continuous compounding along with the continuous dividend yield. Next formula, forward price for a coupon paying bond. Again the mechanism is exactly same. So how will we do it? This is let's say face value of a bond is 1000, coupon rate is 10%, the coupon is paid on a semi-annual basis. Okay. Now the current market value of the bond is 975, and we are, so if this is time 0 and let us say this is time 1, then currently we are at point, let us say 0.7. okay, this is where we want to build a forward contract. So we are, I'm so sorry, that's a mistake. Yeah, so how we can structure the question is, we can say that we are expecting a dividend now. So eliminating this part, we are expecting not a dividend, we are expecting a coupon of 50 at time 0.5, and we are expecting one more, let us say of 50 at time 1. Now what if we want to find out a no arbitrage forward price which has got maturity of 0.7 years? Okay, so we are going to do calculations in the fraction of number of year. So the maturity is 0.7 years. So how will we do it? Exactly same mechanism. The current price which is given to us is 975. So what we will do is we will take this 975 forwards. In the same fashion, we will take this 50 forwards for 0.2 years. If this is A, this is B, your final answer is going to be A minus B. So let us find out future value of 975. Second clear TVM, 975 is present value. Discount rate I forgot to mention, but let me keep that discount rate also as 10%. So 10 is the IY, 0.7 as the N, compute future value. So this A value would come out to be 1042.26. In the same fashion, we have to take 50 forwards for 0.2 years. So second clear TVM, 50 is the present value, 0.2 would be N, 10 would be IY, compute future value, and B would come out to be 50.96, and then we will take A minus B. So A minus B value would come out to be 1042.26 minus 50.96. So it will give us a no arbitrage forward price of 991.3. Okay, so the way we calculate forward price of a coupon paying bond and the way we would calculate forward price of a dividend paying stock, the mechanism is going to be exactly same. So it is essentially the same formula. Moving forward, value of a forward contract non-dividend paying. So please appreciate the difference here. So far whatever formulas we have seen price, we have seen price, we have seen price, we have seen price. Now in this particular formula we are being expected to calculate value. The difference is in the price we found out what should be the no arbitrage price, but in case of value we would be finding out what is the amount of profit or loss. So let us look at an example now. Now this is simply non-dividend paying, so relatively straightforward calculations. So just a minute. Okay, so let us say this is time 0, this is time 1. Spot price here was 100, risk-free rate of return is 10%, maturity is 1 year. We calculated a no arbitrage price which turned out to be 110. Now we have already entered into the contract. Let us assume that we are on the long side, and currently we are at time 0.3. Now the spot price kept on changing throughout this period, and the current spot price is 140. So now the first question from the long perspective, is it a profit or loss? And of course it's a profit. Why? Because we have a right to buy at 110 and the spot price is increasing, which means on the expiry day or maturity day, we would be buying, most probably we would be buying an expensive asset at a cheaper price of 110. So it is going to be a profit for long, it is going to be a loss for short. The question is, how can you calculate that profit or loss? So there are three alternate methods we can use. The first recommended method, though slightly longer but recommended, you can take this 140, so this 140 forwards here. So based on current spot price of 140, what would be the no arbitrage forward price? Okay, so how would we calculate that? We will say second clear TVM, 140 is the present value, 10 is IY, 0.7 is N, compute future value. So this would come out to be 149.65. Now the interpretation is that if I go to a dealer today, I ask him if the spot price is 140, what is the new forward price for 0.7 years from now? He will quote us a price of 149. So at time 1, we have a right to buy at 110. We can enter into, so we already have a long position here. We can enter into a short position on this new contract, so that we will have a right to buy at 110. We will have a right to sell at 149.65. The difference between the two would be your profit. So that amount would come out to be 39.65. But this 39.65 would be your profit 0.7 years from now. So what is the amount of profit that we have today? So again we have to take present value of this amount. So keeping this amount as future value, 0.7 as N, 10 as IY, the present value would come out to be 37.09, and this is the value of the forward contract today, and this was the first methodology. Okay. Now what is the second way in which we can achieve this? The second option is, which is again simple time value of money, that instead of taking this 140 forwards, we can simply take this 110 backwards. Okay, so second clear TVM, 110 is the future value, 0.7 would be N, 10 would be IY, compute present value. This will give us 102.90, and then we will take the difference between 140 and 102.90. So that difference would again come out to be 37.09. So you can also get the answer using this second mechanism. The third mechanism is that you can take this 100 forwards for a period of 0.3. So second clear TVM, 100 would be present value, 0.3 would be N, 10 would be IY, compute future value. This will give us 102.90, and then we will take the difference of these two, and that difference of these two will again give us 37.09. Okay, so whichever method you use, the answer is going to be exactly same. However, the method that I would be recommending to be used on the examination, now this is not recommended, because if you practice using this, and what if on the exam the spot of the original scenario is not given? Okay, so this is not recommended, but it was only for understanding purpose. The method that we've used, this particular method where we took 110 backwards, so this method will work on the exam. However, the method that I would be recommending is this method, where we will take 140 forwards and then we will take the profit backwards. It involves one extra step of computation, but when we go to currency forwards, then this method can be used consistently across different category of forwards. Okay, so moving on to next formula now. Value of a forward contract with discrete dividend. Okay, so in the previous section we saw value of the forward contract, but we did not consider the fact, or we did not took an example where there was a dividend involved. Now let us look at a scenario where there is some dividend. So let us say this is the spot price today, which is 100. This is time 0, this is time 1. No arbitrage forward price is going to be 110. Now let us assume, so in fact we cannot spell out no arbitrage price right now, so let me just hide this section. So let us say that after 0.3 years from now, okay, which is fraction of a year, we are expecting a dividend at 0.3. Let us say the amount of dividend is 20. First question, how to calculate no arbitrage forward price. So we will use a straightforward mechanism. We know that future value of 100 is going to be 110, and let's take future value of that 20. So it would be second clear TVM, 20 would be the present value, 0.7 would be N, 10 would be IY, future value would come out to be 21.37, and the difference of these two, 100 minus 21.37, the no arbitrage future price is going to be 78.62. Now once we have no arbitrage future price, which is 78.62, now this is the pricing part which we have already seen in the previous formula. Now let us say, what if that at 0.2 the spot price has changed to 130. Okay, so now spot prices become 130, and we have been asked to find out value of the forward contract. So in case if you see an exam like this on the question like this on the exam, then what will you do? First you have to find out a new no arbitrage forward price. So how would you find out? This 130 we need to take forwards. So taking the 130 forwards from here, so that will come out to be second clear TVM, 130 is the present value, 0.8 would be the N, 10 would be IY, compute future value, that will give us 140.29. Now once we have this, what we also know is that there is an amount of dividend which is going to come 0.1 years from now, and that till maturity the distance is of 0.7 years. So we will take the future value of that dividend, which would be same as minus 21.37. okay, so distance between the two, the difference between the two would be 118.92. Now once we have 118.92, this is a no arbitrage theoretical forward price, then the distance between or difference between 78 and 118.92, so that distance is or difference is going to be 78.62. that difference would be 40.30, and that 40.30 we need to take backwards for 0.8 years, so making that 40.30 as future value, 0.8 as N, 10 as IY, compute present value. This would give us the final answer as 37.35. okay, now one small trick here that we could have used, or again only for understanding purpose, if you observe, 78 is calculated as 110 minus 21. This is calculated as 114.29 minus 21, which is 118.92. Now we are taking the difference of 118.92 minus 78.62, which is 40.30, and then that difference 40.30 we took backwards, and that gave us the final answer as 37.35. Moving forward, fixed income contract value. So exactly same logic, what logic we used for finding out the discrete dividend value of the forward contract. The same logic we are going to use for fixed income contract value. Value of a forward contract with continuous dividend. So let us look at an example. So let us say okay, just a minute. Spot price at time 0 is 100. We are looking at a contract that will expire in 1 year, and we have been given continuously compounded risk-free rate of return. So let us say the RFR that we've been provided with, which is continuously compounded, is 10%, and we have been provided with dividend yield of 3%. First question, what should be a no arbitrage forward price? Okay, so how would you deal with this? Again, you would say 100 into e raised to r minus d into t. So 10 minus 3, which is 7%. Since t here is 1, we let it remain as it is. Second, e raised to x multiplied with 100. So this would give us a no arbitrage forward price of 107.25. Now let us say that after 0.4 years the spot prices become 150. Again, we know that if the spot prices increase, the long on this contract is going to make some profit. Now how would we deal with this question? We will find out what should be a no arbitrage forward price going further. So this time around we will say 7% into 0.6, because the remaining period is only 0.6. So 7% into 0.6, second e raised to x multiplied with 150, that will give us a no arbitrage price of 156.43. Now we will take the difference between these two prices. So 156.43 minus 107.25, that difference between the two prices would be 49.18, which is your profit. And the value of the forward contract today is present value of this 49.18. Now the only mistake that you do not want to make on the exam, that when you take the present value of 49.418, this has to be done only using risk-free rate of return. You are not going to use RFR minus dividend yield here, okay, which is the most common mistake I've seen people doing on the exam. So now we have to use only 10% to discount it backwards. So how would we do it? We will say 10% into 0.6. We will make this number negative because we want to take present value. Then we will say second e raised to x multiplied with 49.18, and the present value of the contract here, which is your answer, is going to be 46.32. Moving further.